Hey everyone, and welcome to the first video on how to build smart wallets. In this video, we're going to be walking through how to send a user operation and construct it. User operations are smart wallet type transaction. We're going to do a step-by-step guide using Abstraction kit. So without further ado, let's get started. So I'm on Candide docs and I'm walking through the first guide, send your first transaction. We need to get set up. So I already have the folder created. I'm just going to initialize the project using an empty project. And then from there, we're going to be setting up, installing two libraries, Abstraction kit and .env. .env just to load the environmental variables. And then from there, I already added these environmental variables to my project. So you have the chain ID, we're going to be using Sepolia testnet for this example. The bundler URL, so we're also going to be using a bundler on Sepolia. You can get any of other networks if you just click here, and then you're going to see like the other networks or testnets available. You're going to need the JSON RPC node provider. Essentially, you can get this one from just type in Ethereum RPC Sepolia, and you just go on chain list, it's a very good website, and you'll find a public one to use. And then you'll need the private key and the public address. This you can generate using MetaMask, you can generate locally, or you can get anyone. Make sure this is a private key that you won't use just for development, so just add test tokens to it. And then without further ado, let's get started. So I'm gonna open VS Code and I'll split my screen. So here's the env variables that I already added in, and I'll split my screen right here. And then I'm gonna create a new file called the index.t. It's gonna be our main file, and I'll create a function, an empty function, so we can get started from there. All right, so first thing first, we want to generate the account address. The account address here, what we mean by account address is the safe address. We're using here the safe module for fallback for 47. If you want to learn more about this architecture, you can just visit this repo right here. But for the sake of this video, we're just gonna walk you through how to calculate it using Abstraction kit directly. So what you'll need is we're going to be importing from env variables our public address, the public address of the owner of the safe. And only with that value, we can calculate the safe smart account. We don't need anything else. We're not making an RPC call. Everything happens locally. So I'm going to be importing here the safe account v3. So v3 is just like the version that works with entry point v7. If you want to use entry point v6, you can just fall back to v2. So I'm gonna do import safe account as v3 as safe account, so make it easy in the code. And we're gonna load the env variables here. And then we're gonna take the owner public address that we added in our env variables, and we're gonna calculate the address like the following. So we're gonna initiate a smart account instance using safe account dot initialize new account, and we're gonna be passing the owner public address. And that's it. That's all you need. Now to actually print the address, we're gonna do smart account address equal smart account dot account address, and that's it. And then we can console log this, so we can console log this smart account address, and let's try to run this now and see what we get. Don't forget to save. Sorry. So I'm gonna run this code npx ts node index.ts, and once we run this, we're just gonna get our smart account address that we just calculated. Now so the example tells us to fund the account address right now, to go ahead and fund it, but I'm not gonna do just this right now because I actually want to show you what error you're getting if the account is not funded or if you're not using a paymaster to sponsor the transaction. So let's go ahead with the next step. Before I can do that, since I already used this account, which I know, let's go check it out. I think I already used it. So Sepolia, Block Explorer, let's search for the address. So you can see here, it's already funded. So I'm gonna use another account or safe account generated, and you can simply do the following. So you can do C2 nonce, let's say 1. So using that, I'm actually gonna get a new smart account address using the same owner. And you can generate as much as you want. All you have to do is just maybe increment the C2 nonce every time, and you have a new address owner. So we'll go with the C2 nonce now to show you the error, and then we'll later execute the transaction with the funded account. So just to verify, we're gonna go here and see on Sepolia if this account is already funded. Here you go, 0 ETH balanced. Sounds good. So next up, we're gonna be generating the call data. This is the normal transaction stuff that you want to do, either mint or transfer or contract interaction. This is what happens in the logic of the transaction itself. So we're gonna be importing a concept called, what's new for you is meta transaction. A meta transaction is the type of transaction that we represent for safe accounts. It has a to, a value, and the call data itself. And we're going to be importing helper functions called get function selector and create call data to actually help us construct the call data. So here we're going to be minting 2 NFTs all in the same user op. So I'm just going to copy these lines of code here so we can make it faster. And I'll explain them one by one. So this is the NFT contract. This is the method that we're calling mint address. And we're getting the selector of this method so we can actually be able to create the call data for a transaction. So using the selector with the inputs parameters, the address, and this is essentially, we're minting to this address, which is the smart account address. We can essentially do, since we already defined this variable, we can pass it like here. So we're doing 2 transactions, right? The first one is interacting with the NFT contract. It's sending 0 ETH value. There's no ETH value that we're sending, just minting. And this is the call data. And we're just doing it twice. So transaction 1, transaction 2 is pretty much the same. Now, how will we construct the user op? So let's do that. So next step, user operation equal. It's pretty simple. Await smart account dot create user operation. And create user operation takes 3 input parameters, an array of transactions. So we're actually going to be batching this and these 2 transactions in the same one. It takes the JSON RPC node, which we defined, the Sepolia one, and it takes the bundler URL. So I'm going to paste these here. So why does it take, so here we go. So why does it take the node and the bundler URL? So it takes a JSON RPC node provider because we need to fetch the nonce. We know it's 0 because this is the first transaction. But what if it's not 0? We need to fetch that and read that data from the blockchain. And then the last variable is the bundler URL. Why do we need the bundler URL to create the user op? It's actually to estimate the gas for this user operation, estimate the gas limits specifically. And then once we do that, we have a nice method to display the cost for the user. So we just calculate the cost. It's imported from Abstraction kit. And then we pass it in the user operation. And that's pretty much it. Then we're gonna add some console logs to help us console it. And it's gonna tell us how much we need to fund the account in Wave. You can convert that to ETH later on, but it's gonna actually tell us. So let's run this example now. So if you run this example, we're gonna print the account and telling us, please fund the sender account with this much Wave to actually execute the transaction, the minting of NFTs. One thing you haven't noticed is that the account is not deployed. So on the first transaction, the account is going to be deployed. Nothing to do on the code side. Abstraction kit handles this automatically for you. If it's not deployed, it deploys it. If it's already deployed, then it skips this deployment transaction. Now the last step is actually to sign this transaction by the owner. So let's do this. So user operation dot signature smart account dot sign user op, and it takes the user operation. Obviously, it takes the private key, and it takes chain ID. Notice private key here is an array because safe could have multiple owners that have to sign over the same user op. It could be used as a multi-sig, could be used as a 2FA. It's up to you how to want to define the wallet that you're building. So now the private key is the chain ID is in my env variables. So I'll just paste them here and I have a typo, chain ID. Now the last step is to submit the user op. It's pretty simple. Send user operation response, await smart account dot send user operation. And we only need to pass it in the user operation and the bundler URL, which actually submits it for us on chain. And now let's track it. To track the user operation, we're gonna wait for its receipt result equal await, and we're gonna be taking send user operation response dot included. And if it's included, then and it's success, then print us a success. And if it's not, print us what's the error failure. You can also print this transaction hash right here from the receipt. And that's it. So if we try to run this example, remember, we haven't actually funded the account. No one is paying for the gas. So let's see what error we're gonna get from that. So we got here a big error, but what we're important is the cause of the error. And it's called AA21 didn't pay pre-fund. What does it mean? If you don't understand the error message, you can just go in and search for it. AA21 right here, and it says the sender lacks sufficient native tokens to cover the gas costs associated with the user op. That means no one is paying for the transaction. it's not being sponsored, the bundler won't execute this transaction. You need to fund the actual account. Now, I already funded an account, the accounts with the C2 nonce 0. So let's bring it back to 0 here, and we'll notice that it's going to execute. So let's do this. Let's go back and then see if it's going to execute. Here we go. And then notice here we had, since it's not the first transaction, it's not going to deploy the account because I already did that. It has one single transaction that I did before, 2 hours ago, you can see. And then now we're doing the second transaction, also minting 2 NFTs. And let's see if it's going to happen or not. Looks like it's taking a little bit longer than usual, but here we go, it happened. 2 NFTs were minted. Let's check the transaction hash. Here we go. And let's open this window a little bit bigger. Now you saw here, to understand what's going on with this transaction hash. So this is the normal Ethereum transaction hash. You'll see here the from is the bundler, and which contract it interacted with is always the entry point contract. That's the newest version. What transaction happened is actually minted 2 NFTs to our sender. If you remember, this is our sender account. So one thing that is good about Block Scout is that you can actually see the user up transactions, because this isn't a transaction. It could have multiple user operations and not only from your account. So let's go to our account here, and there's a tab called user operation. And we're gonna go see here. This is the one we did 1 minute ago. It's actually quite useful to see all the information related to the user up itself. And it's quite good. And it actually shows you all the information that you need. That's pretty much it. That was how to send the first user up. In the next one, we're gonna show you how to use a paymaster to sponsor gas for a transaction.